Yeah, hello everyone. Am I audible?
Yes, sir, you are audible.
Okay. Okay, so problems for the week 7 live coding I have already published. So you can start the coding from the live coding problem number 1 of week 7. So total we have 5 problems and all are the related to the week 7 contents. So first problem is that write a function decode where there are two arguments root comma ciphertext that accept a variable root which contains the reference of the root node of Huffman tree and an encoded message ciphertext in the form of a string using 0 and 1. So the function returns the decoded message in the form of a string. So basically we have a one Huffman tree. The root of the tree is referenced by the root variable. So you have to traverse the tree, and one more thing, yeah, ciphertext is given basically. So one code is given using 0 and 1 combination. So your function should return the actual message using this open tree. So there is one example given in the problem. Yeah. So for example, this is the Huffman tree for the input, and we are providing one ciphertext. This is the ciphertext 0000111. You can see in the sample input. So your function should return the actual message. What is the actual message for the input? So this is the first problem. So try to solve this problem. If you have any confusion or to understand the problem or any logic, what is the logic, you can ask in between, but first you should try yourself. Once you finished any problem, just type the completed problem number 1, this type of message in the chat box. Yeah, one more thing I want to clarify. Basically, in the last session, in Thursday session, there was one discussion on topic minimum lateness topic. So actually, there was some confusion to find out the minimum lateness. So what will be the actual things I'm just representing? Yeah, this one. So we have discussed this minimum lateness topic in last Thursday session. So one question was arise that what happen if uh, two jobs have the same deadline? If we swap these jobs, so the lateness become changed. But actually, we were confused in the topic. What is the actually lateness? What is the lateness meanings? So in last session, actually, we are calculating this minimum lateness uh, by sum of the all lateness. But actual maximum lateness is means that what is the maximum value in all lateness. So if activity one have zero lateness, three have zero lateness, two three have three lateness, like this. So maximum lateness represent the maximum value of all these lateness. So this lateness value will not change if we swap the process. Those have the same deadline. Last time we are calculating this lateness by the sum of all these lateness. So because of that, the value was changing. So so the problem number one class is given. You have to remember that what are the field we are using in the tree actually. So there is one field frequency, one symbol, there is one left or there is right. So left and right is the field where we are storing the address of left child and right child. Symbol are storing the character actually. So leaf node are storing the actual character in the symbol field, and internal node are storing the characters by the combination of all child character. So if two have B character and three have C character, so the parent node 5 storing the BC combination of these character. So you have to remember these things when you are writing the code. Can you define lateness as sum of individual lateness? No, lateness actually in the lecture we have sir taught the lecture in the minimum lateness. So basically lateness is defined by the minimum value of all lateness. Sorry, no, maximum value of all lateness, not the sum of all lateness. Yeah, Prasar. So lateness means if any jobs are completing after the deadline, so the value is represented as a, yeah, the graded assignment, yeah, that is the different type of problem where we are asking the sum of the lateness, but the actual maximum lateness meaning is different. So once you finish the problem, please send the message in the chat box. Yeah, Parth Bhatnagar. Good, very good. Okay, start second problem part. That problem is basically related to the max value selection. Yeah, that is a popular problem of fractional knapsack. That is called. Just try this problem. So this is the greedy based problem. Yeah, suppose which problem you are asking? Problem number 1.
Yes, sir.
Okay.
Problem.
Yeah, so approach is simple basically. So can just explain. For example, if we have a Huffman tree, okay. So for example, this character is containing the leaf node A, B, C, D, E. Okay, we know that in Huffman tree, every edge on the left side contains the 0, and every edge on the right side contains the 1. 0, 1, 0, 1, 0. This is the meaning. So we are providing the root reference in our function. So this is the root. Okay, so there is one input string. Okay, so for example, 0, 0, 1, 1, sorry, okay, 0, 0, 1, 1, 1, 0, 0, 1. Okay, I'm taking the short example. So every time we will start traversing from the root node and scan this input string from left to right one by one. Okay, so first character is 0. So we will start from the root, and according to this character, so if this is 0, then we will move to the left side. If this is 1, then we will move to the right side. So we will start from root. So first character is 0, then we will move to the left side. Then next character is 0, then once again we will move to the left side. So every time we will check the node is leaf node or not. If node is leaf node, so we will print the symbol of that leaf node. So what is the symbol for the leaf node is A. Okay, so when we reached at the leaf node, so we will just print the symbol of the node A. After printing this thing, so we will just move the pointer to the once again on the root. We will start once again from the root. So there is two symbol have already scanned. So next, what is the next symbol is 1. So we will start from the root once again. So what is the 1? So we will move to the right side. Okay, the next character is again 1. So there once again we will move to the right side. So again we have already reached at the leaf node. So we will print the character E. Okay, now once again we move to the root and we will start again. Then next, what is the next category is 1. So we will move to the right once again. Then what is the next is 0. So now this side. So we have reached the leaf node. So now we will print the D.
So
Once
it
again,
means to first to create the tree, right?
so tree have already created, not required to create.
Okay.
Okay, tree have already created, and in function we are providing the reference of root node. You just need to traverse the tree.
Sir, can you please again repeat? I did not follow.
Okay. Just wait. Yeah. So actually, what are the input of the function? So there is two input in the function. First is the root of the tree, Huffman tree, and second is the ciphertext. Okay, this is the ciphertext in the form 0-1 combination, and Huffman tree is already created, and we are providing the root reference of the root nodes. So you have the reference of root node. Okay, tree of the tree. So for printing the actual character, so every leaf node contains the actual character. Okay, so in the symbol, so there are definition given in the column statement. Yeah, so self dot symbol. This self dot symbol contains the value of the character. Okay.
That is this ABCD, is it?
Yes, ABCD. So, but we have to check the character, the symbol on the leaf node only, not the internal node. Because leaf node contain the actual symbol, otherwise internal node contain the combination of the symbol.
Sir, I also have a doubt with the diagram that we have given. That given in the question.
Okay.
Huffman code diagram. So it is balanced actually, and I'm not getting why balanced. Means the nodes are equal on the both the sides.
It is balanced. So Huffman tree form can be anything. So is there any
Means,
problem if it is
the approach of creating a Huffman tree is the right most less frequent elements, and take the most less frequent elements and make it in a tree, and then another less frequent element. It was like that, right? Then I think
okay.
I'm
So the
not getting.
frequency, so okay, if we are starting from the frequency, so the frequency is 2, 3, 5, 7, 3, 4. This is the actual frequency of each character. in leaf node?
Yes, sir. Yes, sir.
Okay. So what we did in the Huffman tree creation, so we just always pick the two smallest element. So what are the smallest elements? Two is 2 and 3. So we will add, then we get the 5 value. Okay. So
Yes.
after that, what are the next two smallest element?
Next to smallest will be 3 and 4.
3
Okay,
and 4.
okay.
So we will start from the rear 3 and 4. So we will get the 7 value. Now what are the next?
Okay.
Okay, so next is 5 and 5. Next to smallest
5
element,
and
5. So 5 and
5
5.
will be 10 and 4.
Okay, then we have next 7 and 7, two smallest elements, so 14. After the 10 plus 14 is 24.
Oh, understood. Understood. Thank you, sir.
So yeah, come to the logic. So yeah, in the problem statement we have the two variable root and the one is ciphertext. So how we can traverse these things? So we will start from the root and scan the ciphertext from the left. Each time we will scan the one symbol only. So if a symbol is this value is 1, so we know that Huffman tree, every edge on the left side we consider that the 0 and every edge on the right side consider that the 1. So at the time of scanning, if scanning symbol is 0, so we will move to the left side. Okay, we are starting from the root, and according to this symbol we will move to the left side. So first symbol is 0, so we will move to the left side and check that if node is leaf node or not. What is the meaning of leaf node? If node contain no child, 0 child, that means the node is leaf node. So we can check these things. If node have no children, so that means that is the leaf child. So after scanning first 0, we have these at the first node. Then we will again scan the next symbol. So next is 0. So we will move to again left side of that from that node. So finally we have reached on this leaf node. So we will check that this is a leaf node. Yes, we will uh, collect the symbol value. So what is the symbol value is a, and we can print it. Okay, so after printing we just move our pointer to come back to the root again. So we will move to the pointer on root. Then once again we start this process. So what is the symbol is 1. So one sim at the if scan symbol is 1, so we will move to the right side. Once again 1, then we will move to the right side. So finally we have reached at the leaf node. So we once again we will print the symbol e, then move to the pointer, come back to the root node. Once again we will scan symbol 1, then 1, then 0. So 0 is the left, so that means we have reached left. So now we have reached the leaf node, so we will print the D. Okay, then once again come back on the root. So this have completed. Now 0, so first symbol is 0. Move to the left side, then 1, move to the right side, then last one, move to the right side. So the symbol is G. Okay.
Okay, sir. Clear, sir. Clear. Yeah.
Just Snehil has completed. Good. Okay, so we are moving to the second problem. Yeah, this one. So what is the problem is write a method max value selection. Where there are two arguments, items and comma C, that accepted dictionary items where each key of the dictionary represent the item name and the corresponding value is a tuple. Inside tuple there are two value are given, number of units for that item and value of all units. For example, if item name is A, so number of unit represent the how many number of units are available for item A, and value of all units means if, for example, number of unit is 10, so that means the value of all units. So what are the value of 10 units, not the 1 units? Okay, so and function accept one more variable C, that represent the capacity, maximum capacity you can select from these units. This capacities represent the maximum capacity of units you can select from all the items. So what is our purpose? So you have to select the maximum unit to get the maximum value. So here one sample input is given. So there are 3 item available. The item number 1 have 10 units. The total value of 10 unit is 60. Item second, there are 20 units. Total value of 20 units is 100. And third is 30 unit, and value of 30 unit is 120. So, and capacity is 50. So your function should return the maximum value by selecting the units from all items. So this problem is also similar to fractional knapsack. Popular problem.
Sir, does this mean that 50 items we can, we have to produce 50 items? Is it like that?
Yes, yes. No, 50 units.
Yeah, 50 units we have to produce. So, but 50 units, sir, the number could be very high, no? It could be 30.
Yeah,
30
so
into
total
120.
yeah, we have 60 unit actually. So you can pick the 50 units from these 60 units.
But sir, how will it be 240 and not 220? Like 20 plus 30 is already giving us.
No, this is the maximum value.
Okay, okay.
This is the value, not the unit.
Understood.
So do we have to check for like every combination in this problem? You're on mute if yeah, saying something.
Oh, sorry. Not combination. There is one logic. You can use the greedy approach here,
Okay.
or you have to return only the maximum value
Yeah.
of selection. Okay, so okay, I'm giving some hint. So what are the actual problem is? Oh, okay, the problem now. Yeah, so 10, 60, 20, 100. So item 1, 10, total value is 60. And next is 2, 20, 100, 3, 30, and 120. Okay, so we have these combination. So after getting this, you have to calculate the one unit value for each item. So what is the one unit cost is for this first item is 60 divided by 10, 6. Okay, so what are the second, that is
Okay.
5, and what is for the third is 4. After calculating this, you have to sort these items according to the maximum to smaller size. Okay, it is already sorted accordingly. So what are the capacity of our is 50. Okay, so you will start taking from highest price item. Okay, so this is the highest price per unit. You will collect these all 10 for this. So first is 10 of item 1. Okay, now what is the capacity is remaining? 40. Okay, so you can pick all these 20, then 20 of second item. Now what are the capacities remaining? 20. So now we have 30 items for 3, but we can pick only 20. So now 20 for 3, third item. So what will be the total cost is 10 into 6, 60, and 20 into 2, 40, and then 20 to 3, 60. Sorry, yeah, what the cost is? Oh, sorry, I'm completely 20 into 5. Okay, 100, and 20 into 4, 80.
Yeah.
What is the sum of these completely? So it is 240.
40.
So this is the concept.
This is like that trainer's problem on Code Chef.
Oh, I didn't see the concept problem actually. Okay. Okay, Snail, you missed it. Just wait. Yes, Snail. So we have actually for this is for the first sample test case. So we have three item, item 1, item 2, item 3, and these are the units. So we have 10 units for item 1, 20 units for 2, and these are the 30 units for 3. And these are the total cost. 60 cost is for 10 units of first item. Okay, this is the total cost, and this 100 is for 20, and this 120 is for the 30. So this is we have this input, and after this we will calculate the per unit cost for each item. So what is the per unit cost is for item 1 is 6, and for item 2 is 100 divided by 25, and what are the item per item cost is for item 3 is 120 divided by 30. This is 4. So after calculating this per unit cost, we will sort our items according to the decreasing order of the cost. So now this is already decreasing in decreasing order. So item 1 is greater than 2 is greater than 3. This is the order of cost of item. So after finding this, we will pick the highest cost item first. Okay. So we have initially 50 capacity. We will check that for item 1. So how many units are available? So units are available 10. Okay. But our capacity is now 50. So we can pick all. So we will pick the 10 units for first item. After pick this, so what are the remaining capacity is 50 minus 10, 40. So we will check against the second item. So what are the total items available? So 20 items are available. So 20 is also less than our capacity. So we will pick all 20 for second item. Now what are the remaining capacities? 40 minus 20 is 20. Okay, so we will check the third item. So total 30 units are available, but our capacity is only 20. So we will pick only 20 units from these 30. So we will pick 20 for third. So now capacity remain 0. So after selecting this, we will calculate the total cost. So what are the costs for 10 of item 1 is 60. For 20 items for second, 20 unit of second item cost is 20 into 5. So this is 100. And this 20 into 4, this is 80. So what are the maximum value is 240.
Sir, how the last one got 80?
Actually, we pick the 20 units from the item third. So per item cost is 4. So 20 into 4, 80.
Oh, okay.
Okay. Yes, Srians is asking for the code. So yeah, this is the solution code for problem number 1. Actually. Okay, so this is the function name decode, and these are two in argument, root and ciphertext. So we will just create a string variable message. Initially it is empty. Now we will just take a variable and assign the root. This is the temporary variable, and we are assigning the root reference inside it. After that, we will start the scanning of our ciphertext for I in ciphertext. If I equal to 0, because our input is in the string format, so we are actually writing is the string format. If I equal to 0, then we will move our pointer temporary pointer temp equal to temp dot left. If I equal to 1, then we will move to the temp equal to temp dot right. So temp equal to temp dot right. After that, we will check the node is leaf node or not. So we will check if temp dot left equal to none and temp dot right equal to none. That means node have no children. If this condition is true, then we will collect the symbol from the node. Message equal to temp dot symbol. After doing this, we will just come back onto the root. So we will assign once again temp equal to root. So after completing this scanning process, we have collected all the symbol. Now finally we will return the message. So this is the solution for first problem. Have anyone complete this problem number 2? Just send the message in chat box. Okay. Yes, Neil. Okay, not getting the right answer. Okay, can you send your code? Okay. Or items dot key append. Okay. Total common number. ID. So total common number equal to 0.04 IND, it's equal to 0 break. So what is this number? This is the I. So what you are doing in this loop? So I in D. Okay, so D is the sorted list. Okay, so what is the first item is the per unit cost and item I0. This is the ID. Okay. If C equal to 0, C means capacity. Okay. Breath. And now equal to 1. Snail, what is this num actually?
Sir, the number keeps a track of how many, the number of items that are to be added.
Okay, so now if C equal to 0, then break. Okay, now break 1. Num equal to okay. If num is greater than or equal to C, okay, you are picking the unit numbers of items and then checking the capacity. It is greater than capacity, then num equal to no. So where you are calculating the value actually?
The value of what, sir?
Maximum value. Actually, in question we are asking for the maximum value, not the maximum items.
No, so total takes the maximum value, right? I0
Yeah.
is the value of one item times the number of items of that we can have in the second last line.
This is the total. Okay, total
Yeah.
plus equal to I0 now. If num is greater than C, num equal to minus C. Okay. If num equal to C. What is the butterfly code? Sorry. What is one test case is pass.
I found the mistakes. I found the mistake.
What is the mistake?
So in the first condition where I say num is greater than C, I'm writing num equals to num minus C, which is wrong. Because, for example, if I have 20 capacity and I have 30 elements, then I should be able to add 20, not 10. So it should be num equals to C rather than num minus C.
Okay, corrected now. Okay, just I'm showing the solution for this. Okay, yeah, this is the solution for problem number 2. So here we are there is one we are initialize the one item list with the empty list. Okay. After that we are appending these all items after the calculation of the per unit cost. Okay. In item list we are appending all items after the calculating of per unit cost. So the first value is representing the per unit cost, and second value is represent the I. Okay, this represent the item name, and this represent the total unit. I think zero. Sorry, J I comma J. So I represent the item name, and J0 represent the total unit. Yeah, and first value is represent the total cost, per unit cost. So after calculating this, we are just sorting this list in the reverse order: highest cost first and the lowest cost in last. So we are just initialize the one max value equal to 0. After that, we will in for loop we will traverse per items from the items list. So first item we will take as the per which have the highest cost. So using this for loop, this item variable will take the items from the items list, and every time we will compare that if capacity is greater than the total items value. So this field is containing the total items available. If capacity is greater than total items available for a particular item, so we will add the max value plus equal to the cost, item 0 into item per unit. So total number of units and per unit cost. That means we are selecting the all items for that, all units for that items. After selecting these units, we are so we will reduce our capacity, C equal to C minus total number of items we have selected. And if this condition is not true, that means our capacity is either equal to the item units or less than. So in else condition, we just add the value of the remaining items. So max value plus equal to C dot items. So these items may be either the equal of the capacity or maybe less. So we will add this value. After that, we will just reduce our capacity in equal to 0, and then break the process. So finally, after completing this for loop, so we will get the maximum value of the total cost. Sounds Correction. Yeah, we can just check. We have to just debug the code. Yeah, this is the previous code. So for I in c equal to 0 break, the num equal to this, we are picking this num. If num is greater than c, that means capacity is less. So here, so that value is c. So capacity num equal to c. Num is greater than c. So num is the total item available, and we have the less capacity. Yeah, so equal to c. Actually, this is a different type. C equal to 0. Yeah, so equal to c. Just test it. Yeah. Yeah, pass the test. So this is the correction. Here initially the value was num equal to num minus c, but we have less capacity and items are more. So we can pick only the total items only equal to the number of capacity. So here the num equal to, we will take the num equal to c. And after that we will reduce our capacity to 0. So in next loop, this condition will come, c equal to 0, then this loop will terminate. So after that, we will return the total cost. Yes, Rian, got it? Okay. If you have finished problem number 2, so you can pick problem number 4, because problem number 3 is easy to understand, but the code for the problem number 3 may maybe take some more time. So I'm explaining the what is the problem number 3. Actually, a task manager receive different tasks at the same or different times in a day. Okay, so and he follow the shortest task first strategy to finish task to reduce the average waiting time for all tasks. Each task takes some time to finish, called worst time. So this is the time which task takes for the completion. That is called the worst time. At the particular time t, manager select shortest worst time task to perform next from all tasks received till time t. The new task only can be started after the completion of the current running task. So the problem is easy. So what is the problem? For example, if we are, so here actually task is coming dynamically in a day. Not, we have not collected all the tasks initially. So for example, if we are starting from the 0 time, so initially there is only, we have only one task with t1, which is so which is starting from 0 to, so there is one for, this is starting from 0, and the worst time, that means completion time is, for example, 4. Okay, so this is the completion time, and any other value is given. Yeah, arrival time, burst time, your task id. Okay, so t1, yes, it's enough. Okay, so initially we have only, when we are starting from the 0 time, so initially we have only one task. So we will start from this, so we will start this t1, and it takes 4 times. Okay, so when we reached at the 4 time, that means we are just processing this t1. In this duration, we have received more 2 tasks. Okay, so in this duration, for example, we have received T2, that is starting time, for example, 2, and completion time is 5, and T3. So next is, for example, 3, and completion time is, for example, 1. Okay, in this duration, during this is the fourth duration. So starting from the 0 to 4, we have received 2 more tasks. Okay, so we will select the task which have the smallest burst time. So what are the smallest burst time is 5 and 1. So the smallest burst which is the smallest, T3. So for next processing, we will select the T3. Okay, so we have already one in waiting, and we will perform T3. It will take one time. That means we will reach at the 5 value. So 4 plus 1, 5. So after reaching this 5, once again we check how many tasks are available to perform. So one is already there, and second, maybe some task is also come. So for example, we have received one more task when we have start. So during this period, so there is no one time. Okay, so we have received one more task, for example, which have started 5 and takes 5 number of burst times. Okay, so now at this stage, now we have only 2 tasks. One is T2 and second is T4. So which have less burst time. So both have the same burst time. So in this case, we will select the task. One condition is given, I think. If 2 tasks have the same arrival time, okay. So if the burst time is equal, we will check the arrival time, which have the less arrival time. So this is the less arrival time. Okay, so we will select this T2. Next, if arrival time is also same, so then we will pick according to the task ID, which task have the smaller ID. We will select this. Okay, in this case, we will select T2. It will take 5. So total time is 10. In this manner, we will solve this problem. Okay. So what will be the order of the task performing that the function will return? So yeah, this problem can take more time to solve. So you can move to the next problem number 4. Otherwise, the remaining problem will not cover. That are the small problem. So the one sample input is given. So there is 4 tasks. The first task is coming at the second. Yeah. So task is not in the sorted order. So one, yeah, arrival time is 2, burst time is 3. Second task is arrival time 0, burst time is 4. So we will start from the 2. This arrival time is 0 because of that. After that, this complete at the 4. So at the time of 4, so we have received 1 and 3. Yeah, we have received 1 and 3. So in 1 and 3, so the worst time is the less thing. 3 task 3 worst time is less. So we pick the 3. Then this complete in 2 worst time. So 4 plus 2, 6. Now we have 2 tasks, first and 4. So worst time of the task 1 is smaller than the 4th. So we'll pick the 1. Then remaining is the 4. So this is problem number 3. And problem number 4 is related to the topics which you have covered in the lecture. Is code valid or not? It is also related to the Huffman code. Here code are given for each characters, and encoded message are given. You have to just check that the code is valid or not according to the given Huffman codes. So there are one dictionary is given. So write a function is code valid. There is two argument HF code and message. Here HF code is a dictionary that contain the character as a key and code as a value. So all character with codes are available in the dictionary. And the second argument is message. So you have to check that this message is created using these Huffman codes or not. So approach for this problem number 4 is G. So there is one dictionary. So you can just reverse this dictionary. You can make the value as a key and key as a value. After doing this, you have to just scan the message, and you can just take a string variable and scan the character one by one. So first, for example, the one is present. Just add this one into the string and check it is there is any key available with the one string. If no, just append the second character of the string. So 1 0. Okay. So once again check in the dictionary 1 0 key is available or not. So yes, 1 0 is available after reversing the dictionary. So 1 0 is available with the character E. Okay. So when you find this key value combination in the dictionary, just reset your message into an empty string. And once again, just start from the initial part. So the empty string. So once again, append the one value in the list, then 0, 1 0. Once again, this combination is available. Similarly, you repeat this process and check in the dictionary. In last, if your message has any characters remaining, that means the code is invalid. Otherwise, if your string variable is empty in last, that means the code is valid. I'm just giving one simple example. So for example, after reversing a dictionary, we have these combination 0 0, for example, A 1 1 B 0 1 1 C 1 0 1 D like this, and we have a message, for example 001110101. Okay, so we will just take a variable s, and we with the empty string. After we will append the character of this message s equal to 0, and check that 0 is available as a key. No, then once again append the next. So now s 0 0. Once again check 0 is available. Yes. When the condition is true, then make this string as an empty string. And then once again check from start. So s equal to 1. Now the 1 is not available. Once again add next one. 1 1. Now 1 1 is available. Okay. Same for s equal to empty. So now once again s, this is 1 1, that is not available. Once again 1, next 0. Yeah, so 1 0 is also not available. Once again next 1 0 1. Yeah. So 1 0 1 is available. Yes, so it will come true. Now once again reset this empty string. Now append this 0 s 0, not available, s 0 1 0 1 is not available, s 0 1 1. Yeah, that is available. So yeah, once again mark as empty. So after complete this process, if s is empty string, that means code is valid. Otherwise, for example, we remain one more character in this string. So after this process, s once again become 1. That is not a part of our dictionary. So in the last, if s contain any strings of length greater than length 0, that means code is invalid. So in last we will check if s is empty, then return true. If s is not empty, then return false. How many have finished second problem till now? So only one message I have received in chat box, Nehil. I think he finished. Another's? So remaining are you trying or not? Total 53 participants are there.
Trying, sir.
Okay. Okay, Pras.
So can you explain third question is identicated block?
Which question? Third.
Yes, sir.
Yeah, okay. Okay, yeah. In this problem, actually, we are receiving the task continuously, not the initially. So initially we have not the complete task. So we are performing both things. We are performing the task and this as well as the receiving the task. So I have explained in this slide. So once again, I'm repeating. Yeah. So for example, at the time 0, okay, if we are starting from the time 0, at the time 0, we have received only one task, T1. Okay. So this T1 task have the this is the arrival time and this is the worst time. Okay, so worst time is means that time taken by the task. Okay, so initially at the time 0 we have received only one task, so we will start from this task T1, and during this this task T1, so when we completed this task at time 4.
4.
Okay, so during this performing this task, we have received two more tasks. Okay, again. So these two tasks have the arrival time is 2 and T3 arrival time is 3, for example. So the worst time is for T2 is 5 and T3 is 1. So after completion of task T1, then the manager will select the shortest burst time. So at this time, this 4 time, we have so manager have received the two more tasks. So a manager will select the shortest worst time once again. So what are the shortest worst time task is this
T1.
T3.
T3.
Okay, so the manager will choose this T3 to perform the next task. Okay, so this T3 will perform. So after performing completion of this T3 task, so the time is 5, and manager will check again how many tasks are available to perform next. So now one is remaining from the last, and for example, one more is come at the arrival time of 5. So we have once again received two. We have once again two tasks T2 and T4. Then manager will check who have the smallest burst time. So here the burst time is same. So manager will so if burst time is same, then we will check that who is the smallest T2 is the smallest arrival time. Sorry, lots of noise are coming. Bhupen. Yeah, Bhupen. So at this stage, at the time 5, we have received once again 2 tasks. So one from the previous and one we have received new. So T2
Yes, sir.
and T4. So the first time is same, but the arrival then we will, if first time is same, then we will check the arrival time, which have the smaller arrival time. So T2 have the arrival time is 2, and T4 have the 5. So we
T2
we
will
will
be
we will select the smaller arrival time if first time
Yes,
is
sir.
same. So now we will select the T2. Then what is the worst time is T2 for is 5. So total time 5 plus 5 is 10. Same thing we will repeat till the completion of the all process.
Yes, sir.
Okay,
Thank you, sir.
if worst time is same, arrival time is same, then we will check the who have the smaller ID.
ID. Yes, sir. Yes.
Okay. So
Yes,
yeah, writing the code for this problem is time taking. So because of that, I'm saying that pick the problem number 4.
Okay, sir. Thank you, sir.
Okay. Okay, sorry. Yeah, so this problem number 5 is basically we are checking the is tree balanced or not. So if you have completed the graded programming assignment 1, so I think this is the easy one to solve to you. So that accept root node of the binary search tree and return true if tree is balanced, otherwise return false. So the balance factor basically we have used in the uh, AVL tree. So same formula we will use here. So absolute value, if the absolute value of the difference of left height of the node, left, yes, right, and the right height of the node, if it is greater than, it is less than equal to 1, or we can say that the less than 2, that means the our tree is balanced. Otherwise, we if this value is equal to 2 or more than 2, then that means our tree is not balanced. So we, after calculating the height of each node, we will check the balance factor for each node. So initially height of the all nodes are none. So you have to calculate the height of each node first. Then after you have to check the balance factor for each node. If the value of balance factor is greater than 1, so that means the tree is not balanced. Return. So return false. So okay. So problem number 4, I'm trying to write in the solution code. H so we just check that. I, J, and then we will append this J equal to I. After that, we will scan the message. So initially, for example, I ask you to check this thing. Message. So is Yeah, this is the solution for problem number 4. So we are just creating a empty dictionary or EV, and we are just reversing the combination of key value in this new dictionary or EV. Okay. After that, we are just taking a variable s and initialize with empty string, and then we will traverse the message. One. So this for I in message, so it takes the one character each time. So every time we will append this I character in the string s, and after appending this, we will check that if it is available in the reverse dictionary or EV dictionary. If it is available, then we once again mark as we once again initialize with empty string s. Okay, so after completing this process, we have to just check the length of the s. If it is 0, that means the code is valid, return true, otherwise return false. So this is the simple approach for problem number 4. Now next, problem number 5. So when exactly does self.isLeaf return? Okay, I'm just checking it. Yes, Neil. So where when exactly does self.isLeaf return to? So self.isLeaf, is there any function? So it depends on you when you are returning this, because I think there is no self.isLeaf function is given in the problem. Otherwise, in general, it means that if isLeaf means if node have no childs, that means it should return the true. As in when self dot left and right are none, the value of the node is not 0, right? Yeah, so you have to check this condition. So for example, if you are calculating the height or balance vector, so for example, if we have a binary search tree like this. So, no, okay, I'm just deleting it. Yeah. So for example, if we have a binary search tree, this one. So first we have to check the height. So we can start from calculating the height from the bottom up in bottom up manner. So we know that every leaf node have the height 1. So if the node is leaf node, so we can assign the height is 1. For example, this is 1, this is 1, this is 1. So after assigning the height for the leaf node, we can just adding the value of height to the parent node. So what is the height of this parent node will be? So 1 plus 1, 2. Okay. So for the next node, we will check that what is the maximum height of child. So the maximum height of the child of is 1 and 2 is 2. So we will add the value in 2. This 2. This is 3. Okay, 3. Yeah. And now once again we will check the root height is. So what is the maximum value of the child height is 3 and 1. So this is the 3. So we will add 1 in 3, 4. Okay, so after calculating this height, we have to check the balance factor. So balance factor, we have to check that node are not available. So we have to initialize the 0 minus 0 value. 0 minus 0 is 0. Okay, it's the leaf. We can directly assign the balance factor 0 for the leaf node for each. But when we are calculating this balance factor for like this node that have the only one child, so we have to check that what is the height of left node. So left node height is 1. If right height is not available, so we have to initialize the height of right node is 0. So for example, if you are taking two variable L height and R height, so if left node is available, so you can directly check the what is the height of the left child. So you can directly read this value 1. If right child is not available, so you have to check this condition. If this is none, right child value is none, so you have to initialize with 0 value. After calculating this 0, so you left 1 minus 0. 1 minus 0 is 1. Okay, same for the next. For example, this. So what is the height of left child is 1, and what is the height of the right child is 2. So 1 minus 2 is minus 1. Same for this 0. Now above. So what is the left height is 3. What is the right height is 1. So 3 minus 1 is 2. So if any time if you get this value greater than 2, greater than 1, or less than 1, so you can return the false by the function. So we have to traverse the tree to check the height. We cannot get the height of a node from zero. Yes. Yes, Nihil, it is clear or not? Oh. If node is not available, so consider as the right child or left child height is as a 0. Your code is always returns true. But I think this is the not correct. This is test case false. So that means something is wrong calculation for height or balance factor is happening. I think in private test case, true, false, false. So no, there are two false conditions are available in private test case. So I think some corner keys are missing in your solution. You can use the post order traversal to perform to calculating the height or testing the balance factor. Because in post order traversal we always traverse the left child first, then right child first, then the parent node. So after checking the all child node, we just move to the parent node. So anyone have completed the problem number 5? Snehil, have you finished? Okay, just try. Okay, I'm explaining the solution for problem number 5. Yeah, so basically I'm using the approach of post order traversal. So this is the main function. is tree balanced. So we are using one global variable flag. First, this is the recursive traversing. So if node dot is empty, if node is empty, okay, so it's, yeah, is empty is given. What? So okay, just node balance. Okay. Is empty definition is not given. I think it is given in this suffix code. Okay, or we can directly check that is empty definition is not given. So is empty is returned true when there is no child available for the node. Okay, so if node is empty, then we can just assign the height for node is 1. That means we are assigning the height equal to 1 for the leaf nodes in our tree. So this is the condition for the leaf nodes. If a node is leaf node, so then we directly assigning the height of leaf node is 1. Else, so we will traverse the list in the post order way. So first we will traverse the left child node, then we will traverse the right child node. After traversing both child, then we will move to the parent node. Okay, so this is the post order traversal. So after traversing left child and right child, so we will come back to the parent node. So when we come back to the parent nodes, so we will calculate the height for parent node. So node dot height equal to 1 plus max of height of the left node and height of the right node. Okay, so we can calculate the height of the parent node. During the same time, if we have calculated the height of parent node as well as the left child node, so we can directly check that the balance factor here. So this check function is calculating the balance factor. So what this check function is doing, so it is taking as a node reference. After receiving the node reference, we will check the node dot left equal to null. If there is no child available on the left, so we can just assign the 0 value for the left node height. Else, if it is available, we can directly read the height value of the left node. So this is we have to maintain this condition if there is no child available left or right. Okay, so this is the HL value. So we are calculating the left node height. Same for the right node height. If node is not available, we are considering that the height is 0. Otherwise, we will just read the value of the right node height. So after calculating these HL and HR value, we will just check that the absolute difference of HL minus HR. If it is greater than 1, then we will return the false. Okay, that means tree is not balanced. Otherwise, we will return the true. So so this check method return the value if tree is balanced or not. If it is returning the false, then we will store this value inside the flag. So flag equal to false. Okay. So after after completion of this process, or after completion of this function, so in last we will return this flag value. So this flag value will contain the false if tree is not balanced. Otherwise, this flag value will contain the true value. If tree is balanced, so this value will never change inside the function. So our function will return this same value too, if tree is balanced. Otherwise, it will return the false. So this is the solution for the problem number 5. So I think in graded programming question 1, the same concept is using to insert the node, but I think rotation are the additional things. So one problem number 3 is remaining. So the problem is simple and clear to understand. Just code is time taking, or some maybe the length of the code will large. Just try it in the whole week. If you are facing any difficulty to solve this problem number 3, you can ask in the next live coding session. Okay, any query if you have?
Hello, sir.
Who is this?
Richik.
Yeah, Richik.
Yes, on the last day there was a discussion on the lateness part, and you said that you'll discuss it today. Like there were some problem.
Yeah, I have already discussed in the beginning.
I think
Okay, I'm just
missed.
repeat it. Okay.
Yeah, thank you.
Actually, what was the issue? This one, I think. Yeah, that was the issue. No? So if we are swapping the similar deadline jobs,
Yes.
we are getting the different lateness. Actually,
Yes.
actually we are just we were just wrong in the definition of the lateness. Actually, what is the maximum lateness problem is we just return the maximum value of the lateness in the all lateness value.
Okay.
What we are doing in the last session, actually we are calculating the sum of all lateness.
Yes.
Okay, but that is the not definition of the maximum lateness.
The maximum. Okay. Max
yeah.
of all the lateness.
Yeah, max. Yes. So max of the
okay.
all lateness.
Okay.
That value will remain the same if
Same.
we are swapping.
Got it. Thank you.
Okay. Any other query? Okay, there is no query, so we are closing the session. So just keep solving this problem on the portal. It will help you to make easy the final programming exam. Yeah, bye all.